A uniform pole 7 meters long and weighing 10 kilograms is supported by a boy 2 meters from one end and a man 3 meters from the other end. At what point must a 20 kilogram weight be attached so that the man would support thrice as much weight as the boy? First of all, we are going to draw a bar to represent the uniform bar. So we draw a line or a rectangle to represent the bar as like this. Now the bar is uniform. It's 7 meters long and it is uniform, weighing 10 kilograms. Now the weight is going to be 10 times 10, and that's going to be equal to 100 newtons. So the weight of the bar is 100 newtons. So we indicate that at the midpoint of the bar with an arrow pointing downward. 100 newtons. Now a boy is supporting the beam at 2 meters from that one end. So let's say this end is A, and we'll call the other end B. So the boy is standing 2 meters as a support from end A. So let's use a knife edge to represent that because it's a support. And the distance is 2 meters. Okay. Then the man is 3 meters from the other end. So the man is 3 meters from end B, and it is also acting as a support. So we can represent that as a knife edge too. So, or a pivot. So the distance between the man and end B is 3 meters. So we indicate that here. So we're asked, at what point must a 20 kilogram weight be attached so that the man would support thrice as much weight as the boy? Now, since the man is going to support 3 times the weight of the man, then it means that the reaction of the man is going to be 3 times that of the boy. So let's look for the place to place the 20 kilograms. So let's place it close to the man, because the man is going to have support more weight than the boy. So we multiply that by 100 again. So 20, we're going to have 200 newtons. Now, if the man is supporting 3 times the weight of the boy, then the reaction of the man is going to be 3 times the reaction of the boy. Say the reaction of the boy is R, then the reaction of the man is going to be 3R. So since the beam is in equilibrium, we know that the sum of the upward forces is equal to the sum of the downward forces. So the upward forces are R1 and 3R. So when we add that together, R plus 3R is going to be equal to 4R. So this the downward forces, which is the sum of downward, is 100 plus 200, which is 300. So 4R is equal to 300. From here, we can see that R is equal to 300 divided by 4, which is equal to 75 newtons. So R is equal to 75 newtons, and 3R is going to be equal to 75 times 3. which is equal to 225 Newton. So the reaction of the boy is 75 Newton, and that of the man is 225 Newton. So let's take moment about the boy, the pivot. So let's call that pivot C, and we'll call the pivot at the man as D. So take a moment about C. Now let's determine the distance of the 100 from the pivot, the 200 from the pivot, and arrow 3 from the pivot. So their distances will be, now we know that the distance of A to the center is 3.5. So the distance from A to C is 2 meters. So from C to the center is going to be 3.5 minus 2, which is equal to 1.5 meters. And also from 200 to C, we do not know the distance, so we're going to call that X. So we'll replace that with S, and the distance of D from C is going to be 2 plus 3, that's 5. Then subtract that from the whole length, which is 7. So 7 minus 5 is 2 meters. Moment about C, point C is going to go in the clockwise direction. We'll take moment about C. The 200 Newton is going to go in the clockwise direction. And we'll take moment about C. The 3 arrows is going to go in the anti-clockwise direction. Now we know that sum of clockwise moment is equal to the sum of anti-clockwise moment, since the beam is in equilibrium. So the clockwise moment is going to be 100 times 1.5 1.5, that's the distance, E plus 200 times the distance, which is X. The distance from C, that's S, is equal to 3 arrows, and that 3 arrows is equal to 225 times the distance from, so 150 plus 200x is equal to 450. 200x is equal to 450 minus 150. $200x is equal to 300. So x is equal to 300 divided by 200, which is equal to 1.5 meters. So therefore, we can say that the 20 kilogram weight is 1.5 meters from the boy or we can also say that it is at the center, since the boy is 1.5 meters from the center. So therefore, the 200 kilogram, the 200 Newton force or the 20 kilogram is at the center.